Hello scholars, it's Miss Edwards and welcome to lesson 6.1 Intro to Similarity. And real quick, I want to just start with a very quick story about similarity. Just what does that mean? So let's say I take this picture and I go to CVS to the photo counter and I say I want this picture to double in size. And let's say they give it to me the first time and I say, oh, you've only doubled the width, not the length. They say, oh, I'm sorry, let me try again. And then they give it to me again and they've doubled the length this time, but not the width. So they say, oh, my bad, I got you. And then finally, here we go. So what do you notice here about the original picture and the new one? That is correct, right? The picture is still intact. It's just both the length and the width have been multiplied by 2. And that's what I wanted. That's what similarity is. Just real quick, just an overview of congruency versus similarity. Congruency is when, we did this last unit with triangles, it's the same shape and the same size. With similarity, it's the same shape, or in this example here, it's a picture, but it's a different size. It's bigger or smaller. And I just have to make sure when I ask them to double it or make it bigger, 2 times as big, that you have to multiply both sides, both length and width, both dimensions, and make sure that they're proportional, because if they're not proportional, they're going to look all kinds of wonky there. Okay, so we're going to go into the notes now, and so let's go ahead and highlight what similarity is. And it says that figures that have the same shape but not necessarily the same size are called similar figures. So 2 figures are similar when the corresponding side lengths are proportional. As I was just saying, we want it to look like the same picture. And when the corresponding angles, choose a different color, are congruent, right? So it's the same shape, right? The angles have to be congruent, but it's a different size, but proportional. That's what the corresponding side length being proportional is all about. So this also states here, I'm going to just kind of skim over this very quickly and then go into examples. If you want to use the highlighters, you can to make yours look like mine. But see how side AB is purple, that corresponds to DE. That's going to form a ratio, right? That's going to be equal to the side BC, right, in green, over side EF, that's also in green. Those are corresponding to each other, right? When you put those in a ratio, those are going to all be equal to each other. Like same with AC over DF. If I put those all in a fraction and simplify it, they're going to be equal to each other. That's what makes it proportional. And we're going to go over that in just 1 second. Also, the angles have to be congruent. And then the similarity statement is just saying that triangle ABC is similar to triangle DF, and that symbol is just a little squiggly. No equal in a squiggly, that was congruent, just a squiggly. All right, so what we're going to do today for the first part is determine if 2 figures are similar. We're going to check that the angles are congruent. We're going to put 1 pair of corresponding sides in a fraction and put another pair in another fraction. Then we're going to simplify those fractions and check that the sides form a proportion, meaning that those fractions are just going to be equal to each other. Let's actually highlight that. Proportion just means equal fractions. That's simple as it is. We just have to make sure we simplify those proportions or those ratios, those fractions properly, okay? So let's look at example 1. See if the polygons are similar. So 1A, I have 2 rectangles, right? I have 2 4-sided shapes here, and they all have right angles. That means I have 2 rectangles, right? So what I'm going to do is, again, go from one to the other, make sure they're corresponding, the sides, right? Meaning they match up, they're in the same place. So if I start with this side over here, 16, I'm going to put that over 20, okay? See how these are corresponding, they're in the same position. 16's at the top, 20 is at the top, okay? So I put 16 over 20. Now I'm going to use a different color to show you, like this side now, the 28 is going to correspond to this side, the 35, okay? So it's going to be equal to 28 over 35. All right. So my two sides are corresponding, put them in a fraction, 16 over 20. And my other corresponding sides, put those in a fraction, 28 over 35. Now I have to simplify this and see if they're equal or not. So how do I simplify fractions? Well, I have to look at both numbers and decide, okay, what is the biggest number I can divide both of them by? 16 and 20, they're both even, so I can always start by dividing by 2. But I can see a bigger number, and that would be 4. Hopefully we see that it's 4. If not, just divide by 2 and then divide by 2 again if you need to. 16 divided by 4 is 4. 20 divided by 4 is 5. All right, so now with 28 and 35, it's a little different because they're not even. Okay, I can't divide by 2. I can't divide by 3 because I'd have to add up both digits, and that number would have to be divisible by 3, right? So like 28 is 10. You can't divide 10 by 3, and 3 and 5 is 8. Neither of those you can divide by 3. So I can't do 5 either. They need to both end in 0 or 5. So the one, I used to have to know your times tables, and it's going to be 7. If you're not sure what to divide by, just divide each one by, either 1, 2, not 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be one of those numbers. This one is 7. So 28 divided by 7 is 4, and 35 divided by 7 is 5. Again, if you need help with the divisibility rules, let me know, and maybe I'll print out something. But yeah, once you simplify it, there we go. Those are two equal fractions. So yes, these are similar polygons. Now with letter B. First, I have to check that the angles are congruent. 75 and 80. Up already. Is it passing that first test? No. Right? For these to be the same exact shape. Now, these are both parallelograms, but this one is 75, this one is 80, meaning those are two different types of parallelograms. It has to be the exact same angles and proportional sides. So because they're not the same angles, this is going to be a no. So check the angles first and then go on to the sides. Right? So now go ahead and pause and try number 2, letter A and letter B on your own. All right, let's go over the answer to letter A. So I check my angles, 130 and 130. So there we go. It's the same parallelogram. And now I can check the sides now. So again, let's color code this. So my top is 36. That corresponds to 30. So it's going to be 36 over 30. And then the side here, doesn't matter which side, and that corresponds to 20, right? So my next fraction is going to be 30 over 20. Now, I have to simplify this. Now, I think you guys might ask me, well, does it matter which fraction goes on the left or right? That does not matter. You could have put 30 over 20 equals 36 over 30. But just make sure you match it up correctly. Like the 36 does match up with this 30 right here. And then this 30 matches up with this 20. So make sure you're putting them in the right space, if that makes sense. Like it has to be corresponding. It has to match up. So now let's simplify. 36 and 30, I can divide both of these by, now if I'm not sure, just start with the number 2 because they're both even. I can see the bigger number is 6, so I'm going to divide by 6, and I get 6 over 5. And now 30 and 20, I can divide those by 10, and that gives me 3 over 2. So are these equal fractions? No, it is not a proportion. Okay, and now letter B, I have the same angles, right? Both rectangles, all 90 degrees. So that checks out. So now I have to line up the sides here. So 12 over 8 is equal to, and again, when I say the same position, I'm saying like I have to do 12 over 8, like not 12 over 16. That's what I mean. And then 24 matches with 16. So I can do it like that. Okay. Now, if you know anything about fractions, hopefully you remember about fractions, we can kind of even see like 12 times 2 gives me 24. 8 times 2 gives me 16. So I already know this is going to be equal. So if you want to, actually, let's just do it like that. We can also think of it like that. So this is going to be yes, right? Because this means I can just like, here, I'm going to erase this. I can simplify like this, right? If I can divide both of these by 2, that gives me 12 over 8. This is the same fraction. So you don't have to do the simplifying both sides. You can simplify one side to be equal, like use a kind of shortcut if you can recognize that. Otherwise, just simplify. Once you have 2 equal fractions, it's a yes. They're not equal, it's a no. If you need help with the simplifying, please let me know. But we actually have another part, which is dilation, one last little part. So a dilation is a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. So basically all we're doing is making something larger or smaller using K as the scale factor. So we basically, like I said, with that CVS picture, we have to multiply every side by that same number, right, which is the scale factor. And that's going to keep it proportional, keep it similar. So let's look at, and actually, so there's only an example. There's no try it. So yeah, I didn't think I had enough room to fit a try it. So just do the example with me. If you have any questions, once you get to the practice, you can let me know. But it says, first we're going to write the rule and the original points. So the rule is xy goes to, this is a dilation of 2.5. So we're going to multiply both of these by 2.5. Okay. And then we're going to write the new points using the rule. Oh, sorry, we didn't write the original points. So we're going to write the original points, which are going to be D, E, and F. So D is -1, 0. E is 0, 2. And F is 1, -2. And now we're going to multiply each number by 2.5. And so our new points, right, make sure you have that tick mark. Remember D prime. I don't know if you remember this from a long time ago, but we use these little tick marks to show that's going to be the new point. So -1 times 2.5 is just -2.5. And 0 times 2.5 is just 0. 2.5 times 0 is just 0. And then 2 times 2.5 is 5. If you need help with the decimals, multiplying, you can always use a calculator. And then now with F prime, we have 1 times 2.5, which is 2.5. And then -2 times 2.5 is -5. All we're doing is taking each number and multiplying it by the scale factor here. And now we're going to plot. So -2.50 is right here. This is D prime. 0, 5 is up here. That's E prime. And then 2.5, -5 is going to be right here. And see how, yeah, we've made this bigger by about 2.5. Don't forget to connect the dots. All right. So again, this lesson, all we've done is we've dilated a picture. You're going to do that in the practice. And also just determine if the polygons are similar by setting up your ratios, simplifying them, and seeing if they're equal to each other. That's going to form a proportion. So let me know if you have any questions. I am here. Do not hesitate to ask. And I will see you in the next lesson. Bye.